All right, today we've got a real industrial detective story for you. It's a high-stakes mystery that involves absolutely colossal machines, a series of catastrophic failures, and a completely invisible culprit that was threatening to bring a massive industrial plant to a grinding halt. Okay, so let's set the scene. We're at PT Cement Tanasa, a huge cement production facility over in Indonesia. And look, this isn't your average factory. This place is a critical piece of the country's infrastructure, and it's running these gigantic machines 24/7. But then in 2022, things started to go, well, catastrophically wrong. The powerful motors that drive their giant mills, and we're talking machines as big as a car here, they just started failing in the most dramatic way you can imagine. Their massive steel shafts were literally snapping in two. So what was going on? The engineering team was completely stumped. I mean, these are machines that are built to handle immense stress, and yet they were just breaking apart. This became the central question of a multi-million-dollar investigation. What in the world was destroying these motors from the inside out? Okay, so to really get a grip on just how bad this problem was, we need to take a look at the crime scene. Let's establish exactly how high the stakes were. This wasn't just some random one-off thing. No, this was a pattern, and a really scary one. On May 13th, the first shaft snapped. Then, get this, just a month later, on June 15th, a brand new replacement motor on the exact same machine also failed catastrophically. And then, in October, a completely different, even bigger motor broke. The problem was getting worse. And the impact? Oh, it was huge. We're not talking about small machines here. These were giants, ranging up to 5,500 kilowatts. Every time one of them failed, it meant production was dead in the water for over a day and a half. That translates into massive financial losses, and for the plant's engineers, a deeply worrying mystery. So, naturally, where do you start an investigation like this? You look for a physical cause, right? You start by examining the machine itself for any obvious mechanical problems. The team rounded up all the usual suspects. They checked for things like material fatigue, where the shaft's just not strong enough. They used lasers to check the alignment, they inspected the couplings, they analyzed all the vibration data. But you know what? While all of these things seemed to be part of the puzzle, they just didn't explain the whole picture. Something else was going on. And this is where the case really breaks open. The physical evidence itself. Little clues like pitting and frosting on the metal, it all hinted at something beyond just simple mechanical stress. The investigators started to suspect there was an accomplice, a mysterious electrical force. This is where our detective story gets really interesting. The prime suspect was no longer something you could see or touch. The investigation shifted to hunting for an invisible force flowing right through the factory's veins, its electrical power supply. The investigators started focusing on this thing called harmonic distortion. Now, stick with me here. Think of the electricity in your house like a nice, smooth, calm wave of energy. Well, harmonics are basically a form of electrical pollution that turns that smooth wave into a choppy, jagged mess. It's what we call dirty power. And this really gets to the heart of the problem. On the left, you've got that clean, efficient power that motors are designed to run on. But on the right, that's the reality of what was actually flowing through the plant, that jagged, distorted, dirty power, which creates all this hidden heat and stress. So, the big question is, how does this dirty power actually snap a solid steel shaft? Well, it's a chain reaction. This harmonic distortion creates a dangerous voltage right on the motor's spinning shaft, and that voltage needs to go somewhere, so it tries to escape to the ground. And the easiest path is right through the motor's bearings, creating thousands of tiny electrical sparks. It's like a microscopic lightning storm that's slowly eating away at the bearings, which causes vibrations and eventually catastrophic failure. So to prove their theory, the team brought in the big guns, these super advanced power quality analyzers. They hooked them up to the factory's electrical system, and what they found was the absolute smoking gun they were looking for. At its peak, the total harmonic distortion of the current in one part of the plant reached this number, 31.61%. Now, I know what you're thinking, that number probably doesn't mean a whole lot by itself, but let's put it in context, because this is where it gets crazy. And here it is. This is the key. The regulatory limit for this kind of electrical pollution is supposed to be less than 5%. This plant was running at over 6 times that limit. And look at the shaft voltage, almost 4 times what's considered safe. There was no doubt about it. They had found their invisible killer. So with the culprit identified, the team didn't just put a Band-Aid on this symptom. They went after the root cause with this really clever two-pronged attack. First, to handle the immediate threat, they installed these special grounding brushes on 16 of the most critical motors. Think of it as giving that dangerous shaft voltage a safe exit ramp to the ground. And second, to cure the actual disease, they installed what are called active harmonic filters. The best way to think about these is like noise-canceling headphones, but for electricity. And the results? They were instant and they were dramatic. Just look at this. This chart shows the shaft voltage before and after the fix. We see a massive drop from those dangerous levels of over 800 millivolts on average down to well below the safe zone. That's an average reduction of 85%. Just incredible. And the second part of the solution? Just as impressive. Those harmonic filters took that crazy high electrical pollution, over 30%, remember, and wrestled it all the way down, safely below that 5% limit. Just like that, the power was clean again. So, okay, the technical mystery is solved. That's great. But the real success story here is what this all meant for the business. Because fixing this invisible problem had some very, very visible benefits. It's estimated that just one of these failures, when you factor in all the repairs and lost production, cost the company a staggering 1.3 billion Indonesian rupiah. That's nearly 90,000 US dollars. And don't forget, they had 3 of these happen in just a few months. And this is the kicker. The entire investment for the whole solution, the analysis, the grounding, the filters, everything, it paid for itself in less than 6 months. How? All it had to do was prevent just one more of those failures from happening. This wasn't an expense, it was an unbelievably smart investment. You know, this whole case is just a fantastic example of solving a problem by looking beyond the obvious symptoms. They didn't just fix the broken part, they found the invisible force that was breaking it. And it really makes you wonder, doesn't it? What other critical invisible forces are out there quietly causing some of the biggest problems in the complex systems all around us?